we begin by launching Google Earth Pro. In the search bar, I type Rourkela Airport, Odisha, India. Then click the result to zoom into the airport location, which will be used for flight planning. To mark the takeoff location, I right-click on my places, go to Add and select Place Mark. I name it Home Point. Change the icon color and adjust the altitude to sit at ground level. This helps easily identify our takeoff spot on the map. Next, we define the flight route. Right-click again in the My Places tab and choose Path. You can also use the Add Path icon on the top toolbar. I name the path Flight Path, set its color to blue, and increase its width to 10 for better visibility while zoomed out. Now, I begin clicking to place waypoints one by one along the desired route. I continue placing waypoints to form the entire path. Each click adds a point, and lines are automatically drawn to connect them. Here, I set the altitude of the path to 100 meters relative to ground level and ensure the units are displayed in kilometers. Waypoint placement is completed, ending near the home point. The flight route now fully outlines our drone's path. To better visualize the path and check for terrain conflicts, I extend the path to ground level, which helps reveal any overlaps with terrain features. I scan the entire route to ensure that even at 100 meters altitude, the path remains clear of hills or mountains. This is a critical safety step. Now I export the flight path. Right-click the flight path in the sidebar and choose Save Place As. Save the file in .kml format with the name Flight Path for simulation. After closing Google Earth Pro, I open Mission Planner by ArduPilot. Inside Mission Planner, I move to the Plan tab. I set the waypoint radius to 50 meters, default altitude to 100 meters, and choose terrain for altitude type to measure height relative to ground. Also, I tick the option to verify height. Next, I click Load File, select the saved flight path for simulation.kml and load it into Mission Planner. The waypoints appear on the map with their set positions and altitude. To match the Google Earth visualization, I right-click the map, go to Map tool, and select KML Overlay. Click Yes to load and OK to zoom to the imported path. I now define the home position. It's placed at the center of the runway, between the first and last waypoint. Waypoint 1 is assigned the takeoff command at 0 meters. Waypoints 2 through 5 gradually increase in altitude to 10, 25, 50, and 75 meters, allowing smooth fixed wing climb. Waypoint 52 is assigned the land command. The previous few waypoints are staggered down to 85, 75, 50, 25, and 10 meters to ensure a gentle descent and controlled approach to the runway. Now, I move to the Simulation tab. I set the simulated drone's heading to 268 degrees, aligned with the runway. I also set the simulation speed to 10 for faster testing and select a plane model. Mission Planner prompts to download the software in the loop, SITL simulation firmware. I confirm and ensure internet connectivity for the download. After the simulation loads, I return to the Plan tab and click Right to upload the mission to the virtual drone. To confirm the mission upload, I right-click the map, choose Clear Mission, and then read to reload the mission from the simulated drone. Before starting the mission, I run a terrain clearance check. I right-click the map, go to Map tool, and open the elevation table. This confirms that our drone remains safely above all terrain elevations. In the Data tab, I arm the drone, set Do Action to Mission Start, confirm the pop-up, and click Do Action to begin the flight. The drone takes off from the runway and follows the programmed flight path, passing through all waypoints at 100 meters above ground. It clears terrain smoothly, even over high ridges. Ends the flight with a gentle and precise landing.